It's the biggest volcano that we have in our solar system. Everyone's definition of a hellscape. Ice volcanoes are really interesting for microbial life that could be potentially living there today.
So, aliens.
Aliens, yeah. Volcanoes are ultimately a way of getting stuff that's inside a planet out into the outside of a planet. You know, that's ultimately what it's all about. It's all about that planet releasing heat and also just kind of spewing out material out onto the surface, even the moons as well. So our own moon was also covered in volcanoes and had huge volcanic eruptions much earlier in its history. When you look at the dark patches on the moon, that's huge lava flows, you know, that erupted billions of years ago. The Olympus Mons on Mars is an absolutely gargantuan volcano. It's the biggest volcano that we have in our solar system. The actual space it covers on the surface is kind of the equivalent to the size of France, and it actually reaches up into space about 25 kilometers, you know, which is about 3 Everests all stacked up on top of one another. When we're looking at Mars or when we're looking at the moon, we're very much looking at volcanoes which are, you know, extinct or at best dormant. Io, which is a moon around Jupiter, is the complete opposite. So Io has about 400 volcanoes kind of littered across its surface, which just gives you a sense of just how volcanically active this little moon actually is. Io, I think, is everyone's kind of stereotypical definition of a kind of hellscape. You know, it's just sort of nuts, the amount of volcanism and volcanic activity that we see on that moon. It's kind of fire and sulfur and brimstone and all this kind of thing, you know. So you have huge pools of sort of molten lava everywhere. It has these huge fire fountains which go up to about 500 kilometers out into space from the surface of that moon. The kinds of volcanoes which I like and that I'm really interested in are the kinds of volcanoes that can interact with water. Or volcanoes which are actually entirely revolving around ice altogether, so ice volcanoes. We typically find ice volcanoes in the outer solar system, so beyond the asteroid belt. So ice volcanoes are in some ways quite similar to what we otherwise think of as our kind of traditional rocky volcano here on Earth. It's the same process of, you know, getting stuff from inside a planet or moon to the outside surface. It's just the actual material that's being erupted is water and ice rather than lava and rock. So when we think about the icy moons in the outer solar system, beneath that icy crust they actually have either a lens or an ocean of liquid water, and that's ultimately then what's going to be erupted onto the surface to form these ice volcanoes. So like the moon Enceladus, for example, is an icy moon around Saturn. It actually has these huge plumes which emanate out of its south polar region. They actually reach out to about 700 kilometers beyond this little tiny moon. And they actually reach so far that these plumes actually then contribute to one of the sort of very thin rings around Saturn. Because we have such amazing technology now that we can actually fly through the plumes of Enceladus, for example, and actually measure the chemistry within those plumes and see what that information can tell us. Ice volcanoes are really interesting for microbial life that could be potentially living there today, as a sort of example of an extraterrestrial environment that could actually be feasibly habitable for extreme forms of life. And when we want to explore the solar system, that's obviously a super challenging thing to do. So somewhere like Enceladus, which is actually already kind of spewing out a lot of this material onto the actual surface of that moon for us to go and explore, looking for evidence of life beyond Earth.
So, aliens.
Aliens, yeah. Microbial aliens. So we can actually use terrestrial microorganisms kind of taken from, again, similar kinds of environments here on Earth, perhaps really salty environments or really cold environments, and then, kind of subject them to these kinds of extraterrestrial environments to see how they behave and whether or not they survive, and also what other chemicals they might produce, which will then be left behind for us to actually find. So microbes are amazing because they can harness all kinds of different chemicals to use as their food, basically. So you can have microbes which can get energy by sort of using sulfur, for example, or iron, which is present in the rocks around them. And those are the kinds of elements that we get around volcanic systems as well, which is why volcanoes are so interesting in terms of thinking about habitable environments for life. So volcanoes kind of locally deliver a lot of these kinds of elements which life can use for getting energy. And that's why we think that there could be places out there in the solar system which could actually be harboring life, perhaps on these icy moons kind of at this present day, which to us are really extreme places, but perhaps to a microbe living there is kind of just fine. It is a matter of time now as to at least being able to answer the question whether or not there either has ever been life beyond Earth, or if there is in fact somewhere else in the solar system currently inhabited by living things. It will almost certainly be something like microorganisms. So I think either way it's exciting. If we do find life elsewhere, that's obviously incredible, but likewise if we don't find any life anywhere, then that just makes Earth even more special. I wish more people appreciated microbes. They're just everywhere, and microbes should be appreciated.